Hello everyone, let's continue creating Pong from before, from yesterday. Okay, so we have pedal left, pedal right, and ball. Now we are going to create a class pedal and class ball. Let's create a folder called game object and create a pedal class. Okay, then we using the XNL library, then using system. Okay, go now. We create a class, pedal class. Okay, so a minute. So pedal actually have position, so we can do we create a public vector to position. I'm just using field so we can do direct using from here. Then we can use vector to direction. Then can use we can set properties speed maybe. Let's set. Okay, I forgot about the float variable. Okay, now what else? Oh, width and height. Let's add width and height. We use properties again, but I think I want to prefer it. Okay, so then public and height get. Cool. Now let's create the construction. Okay, let's pass our vector. Then do I need direction? No, direction will handling in here. So position, then maybe we use speed in here. We pass speed, and then we passing width and height. Oops, we use lowercase. Now we assign it. Okay, then speed, then width, then height. Okay, so direction should be use vector 0. Okay, so this is our pedal class. Now we can delete this. We use pedal left and then pedal right. Okay, we have some error. Let's delete the old syntax and we instantiate our paddle here. Paddle left, new paddle. Let's put our constructor in here. Oops. What do we need? New vector, because this is position. Oh, I should not get syntax from before. Okay, we need to type again. Virtual height divided by 2, subtract by paddle height divided by 2. Okay, oops. Then we need a speed. Do we have a speed? We don't have a speed actually. Let's create in here. Speed, paddle, and bong. Plot paddle. We differentiate speed for paddle left and paddle right. So paddle left have their own speed and paddle right have their own speed too. Each will 120 F maybe. Okay, now let's create a paddle right speed 100 F, and we can now add again ball speed 100 RPF. Okay, then we back to our paddle constructor. Speed, paddle left speed, then paddle width, then paddle height. Okay, we just copy this and change name to right. Okay, it just change the position virtual subtract by 15 and change the speed right speed. Okay, now we can create a ball class. Let's close this first. Okay, ball class. Like before, we using system. We create a class ball. Okay. Okay, what do I need to create a class ball? Let's see. So where is the ball? Oh, here. We have position and velocity. So let's create it. Public like before. We just use a field for position. Public vector to velocity. And what else? Size. Public. And well, let's just use properties in here. Okay, what next? Do I need a speed? Nah, let's just skip a speed. So let's go to create a constructor. Okay, we need a passing position. Then just size, I think smaller constructor is okay too. Okay, then we assign it. Size. Then velocity. Just put a vector here. Okay, cool. Now we can just delete our ball here and change it to bulk, and we use class. Okay, let's see. Okay. Oops. Let's instantiate our ball here. New ball. The position new vector 2 virtual width divided by 2 subtract by ball size divided by 2 load virtual height divided by 2 subtract ball size divided by 2. Then we need a size, just ball size. Okay, but why do I get an error here? Oh, okay, now we have an issue with, oh, we need to get rectangle from here. Okay, so public rectangle, we need a rectangle, we call it fonts, get new rectangle. Wait. And using matron position.x, then .y, then size. Okay, but why do I get an error here? We might get error. Oh, we don't have a return. Nah, need to return our rectangle. Cool. Now we need to do that. Our pedal need to have rectangle too. Public rectangle bones, but we use this more simple new rectangle. Matron position.x, passing position.y, then we need a width and height. Okay, let's go here. Now we don't need a rectangle here, we can just put the properties bone in here. Okay, let's see. Okay, there is no different from before. We just change our game object works. Okay, now let's create logic so our pedal and our ball can move. Okay, so I'm really bad in math, so I hope I'm doing this well. So what do I need to do for? Oh, let's create a handle input first. Let's create refactory handle input. Then we need to our paddle left direction. We need to restart every frame. Then let passing our keyboard state equal keyboard get state. Now let's make this thing move. If current state is k down, is dot up, paddle left dot direction dot y, up or up -1. Let's copy this, change it to down. Oops. Okay, then we can we create delta time first. Seconds. Then we passing to the position of the pedal. Pedal left position is equal pedal left direction times delta time times our pedal speed. Okay, let's see if this thing work. Oh, I forget I'm not passing our handle input first. We need to pass our handle input in here. Okay, let's see if this thing work or not. Oh, look at that, man. My pedal are moving. Cool. Now, but I think we can do better. Let's just create our app update in here. So let's create public void update. Then okay, select before position equal. Oh, we need to pass our delta time here, and let's clamping in here too. What do I need for clamping? I need a viewport height. Let's just go vh. Okay, position, direction times delta time times speed. Okay, that's cool. Now we can clamp. How do I clamp it? Position dot y using mat dot clamp. Okay, position dot y 0. Then what do I need to pass in? I can forget about this. Value Python. Okay, if I'm not wrong, the VH minus height, I guess. Let's see. Okay, we need to pass in pedal left, delta time, and virtual height. Okay, where do the update. Okay, let's see if this clamping or not. Oh, look, let's work. that's cool. Now what are we gonna do? Let's move the ball first. The ball, what the ball need to do? Let's grab the angel first. Angel, okay, float. We don't have a random. We need to add a random first. Okay, random, and okay, let's insert here. Okay, so the formula I get it from an AI, so this is very great. But anyway, let's move on. Random the next doubles. So this line just randoming our ball to 13 to 60 degrees, if I'm not wrong. Mat dot pi divided by 3 subtract by mat dot pi divided by 6, and we need the float direction of x-axis. Let's just to our AI, so the ball is going always to the right, then we passing to our ball velocity, and in here we new vector to direction x multiply with mat cos angle. Then for the y we use sinus mat cosine angle, and we need to multiply it with ball speed, so we don't need to normalize our velocity, I guess. Okay, I guess that's good. What do I do next? We need clamp and update it in here. Let's see, ball position plus equal ball dot velocity kali di delta time. Let's see if the ball move or not. Okay, the ball is moved. That's pretty good. We're going to use the same method as our pedal. We create our update here. Okay, public void update. We passing delta, and for clamping as well we passing our virtual height, and like before, position plus equal velocity times delta. And for clamping, if our ball if our position less equal than 0, our position y, we clamping the y-axis equal 0, then the velocity dot y, so the ball is going to back again. We use absolute for the ups, then passing our velocity, then else if position dot y greater than virtual height subset of ball size, Okay, the position.y equal vh subtract size. Okay, then the velocity.y minus, so the ball is going to bounce back up, ups velocity.y. Okay, that's cool. Let's go back here. Where's my update? In here. Okay, the ball that update unit dt and virtual height. Okay, that's cool. Okay, that's work. Now we're going to create an AI. Private void paddle right AI. Okay, so what is almost same with our handle input. Our paddle right dot direction had a vector 2.0. Then what else? Okay, if our ball velocity dot x less than 0, we need to return. Oh, sorry, we need the velocity. So return where it will be going to back to the center again if our ball moving out to our pedal right. So we need to target, then we need to set up our pedal to flat center pedal. Okay, so center pedal y. So we need, what we do, we need center, we need a curve, we need pedal right dot position plus pedal height divided by 2. Okay, but why do I, oh, we need to the y, so the origin is going to be center here. Okay, what next? Next is we need to our ball dot position dot x if our ball greater than virtual width. So if our ball is greater than center, our pedal need to targeting our ball. So targeting the center of the ball position. Ball dot position dot y plus ball size divided by 2. Then else if, nah, just else. Else target y is going to back to center. That's it. Then let's create this thing move. If target y greater than center pedal y plus 2, so the pedal is going to be smooth. Pedal right dot direction dot y is going to down, else if target y less than center pedal y minus 2, pedal right dot direction dot y minus 1. Okay, that's cool. Let's see. Oh, I'm not passing this to our update. Let's passing this pedal right AI. Okay, let's see if the is not moving. Y is not moving. Oh, we're not yet update in here. The virtual 8. Okay, let's see. Okay, our pedal right are moving. Now we need to check the collision. If wait for it, check collision. Oops. So how do I check a collision? It's pretty simple. If ball dot bone intersect our pedal left and ball dot velocity less than 0, velocity dot x pedal left dot bones. So what it will do? Okay, all the position dot or ball position dot x should be passing the paddle left dot bounce dot right. Okay, and our ball velocity dot x should be bounce back to our x-axis. So the velocity x we time it 3%. So every ball will going the speed is going up every 3%. Okay, then we have I get a formula about the randomness of the y-axis. So we can do this float run next double times 200 minus 100. So this is will make the ball random more fun for the pedal game. We're going to do the same with the pedal right. We just change the name. Right bone ball velocity greater than 0. Our ball position X, pedal right, bones left. Then everything is same except for the bones. We need it to be minus. Okay, that's cool. Then we pass into our update. Check collision. Okay, let's see. Okay. Now this is a Pong game, everyone. Our Pong game work as good, but it's kinda the balls is not really smoothing when it move. We can do targeting our elapsed time, and we need time span dot from second 1.0 divided 120.0. Then so I'm just put the frame 120. Monogame usually use a default FPS 60 FPS. I just raise the frame into 120. Then we need to use a fixed timestamp here to true. So here we now. Okay, that's cool, isn't it? Okay, we don't have I think for next, I think I stop here. We always is most the time is 34 minutes. It's almost half an hour. Okay, so I think we stop here, and then for next video I'm going to use a game stat and make the score works. That's all everyone, thank you very much for watching. See you next time, bye bye.